So the title of this video is Making Imaginary Roots Real, okay? And where this comes from is I had read an article about helping students visualize imaginary roots, and I want to share that with you, okay? So what we're going to do here is I'm going to start with what I'm going to call task number 1. And we're going to kind of see the connections between the two. So the first thing we're going to do is I want you to graph and find the roots, okay, of this parabola right here. F of x equals negative quantity x minus 2 squared minus 3. All right, so hit pause if you need to copy everything down. But when you're ready, I'm going to go ahead and start with the graph so that we can start, kind of visualizing what kind of roots we're going to have. So I recognize that this is in vertex form, okay, and this is going to mean that the parabola is shifted right 2 units and shifted down 3 units. And so the vertex, okay, is going to be positive 2. The vertex is going to be a positive 2, negative 3, okay? So positive 2, negative 3. Now, because of the vertical stretch here of 1 and the negative is an x-axis reflection, I know that our parabola is going to have the normal vertical stretch of a y equals x squared parabola. So it's going to go over 1 unit for the vertex and down 1 each way. And then we're going to go over 2 units from the vertex and we're going to go down 4 units each way. Okay? So just bringing back that little connection with the graphs. So here's the parabola, and we can see that this parabola is going to have 2 imaginary roots. Okay, I'm going to go ahead and erase this part. That was just to kind of help you with the graph right there. Okay, so we're going to have 2 imaginary roots. So what we're going to do over here is I want you to solve this parabola. Well, if I'm given a parabola in vertex form, the best thing to do would be to set the equation equal to 0 and solve it algebraically. Okay, so we are going to add 3 and then divide by the negative 1, and then you can see when we square root both sides, that is where we're getting the imaginary roots because we're square rooting a negative. So it's going to be plus or minus I square root of 3. All right, so the roots are 2 plus or minus I square root of 3. Now, let's just go ahead and, kind of leave that there. So we've got a visual of the graph. We can see that the roots, we've got the exact imaginary roots. Well, here's what we're going to do in task number 2, okay? Task number 2, I want you to write a related parabola. We'll talk about what that means in a second, with real roots, meaning that we're going to graph a parabola that is very similar to this parabola, except the roots are going to be real. Well, if we take this parabola, right, and we take this parabola that's in blue, and I reflect it, and I make a parabola that has the same width and the same vertex, but I make it open up, then we can say that the parabolas are almost identical, except that the green one is going to have real roots and the blue one is going to have imaginary roots. So the related parabola is going to look like this. F of x equals x minus 2 squared minus 3. So basically, we have the same vertex. Okay, I'm going to try graphing this green one just a little bit more accurately here, so I'm going to get rid of this. So basically, we've got the same vertex and the same vertical stretch. We're going to go over 1, up 1 each way, over 2, up 4 each way. I was just a little bit off with this point right here, so I'm just going to try to delete those out. Okay, and then reflect this over. And so this green parabola, like I said, is almost exactly the same as the blue one, but it has real roots. So what I want you to do now is I want you to solve this related parabola. And you get x minus 2 squared minus 3, and to find the roots, we set it equal to 0. Okay? And then we're going to add the 3 over and square root both sides, and you can see that the solving process is almost identical. It's just that now you're square rooting a positive 3 as opposed to square rooting a negative 3, and you get 2 plus or minus the square root of 3. So I kind of want to ask you right here, when you compare the roots from task number 1 and task number 2, what do you notice? okay? And what you notice is that the roots are basically the same. So if this parabola in green has roots 2 plus or minus the square root of 3, well, then the related parabola that doesn't cross the x-axis is going to have roots 2 plus or minus I square root of 3. And so really you kind of think about it that you're really solving the roots of the green one, but because the blue one doesn't cross, that's why we're going to put an I right there. Okay, so let me just kind of go on and just, really try to cement this connection. So, ... okay, if, let's suppose we have this parabola, right? And this parabola right here has roots that is, let's see here, let me do this first. 1, 2, 3. Okay, so let's suppose that we have a parabola where the roots are 1 plus or minus 2. Okay, so that would mean that 1 plus 2 makes one of the roots 3, and 1 minus 2 makes one of the roots negative 1. So let's suppose we have this parabola where the roots are 1 plus or minus 2. Okay, well then the related parabola, if I take the same parabola and I flip it upside down, right, then this is going to have roots 1 plus or minus 2i. Okay, and so that's really kind of what you are doing is you're solving the related parabola, but putting an I there because they don't actually cross the x-axis. Just one more quick kind of connection. If you have a parabola, okay, where maybe it kind of looks like this and it opens down, right? If the roots of this parabola is negative 5 plus or minus the square root of 2, then what is the roots of this related parabola going to be that has the exact same width, exact same vertex, but opens up and doesn't cross? Well, the roots are going to be negative 5 plus or minus I square root of 2. Okay, so if nothing else, like I said, this video was not about teaching you anything new. It was just connecting the imaginary roots and showing you a related parabola that has the same real roots. Okay, so anyway, hope this helps and thanks for watching.